All right, so today in geometry, we're going to look at factoring polynomials that have a leading coefficient greater than 1. So the very first thing we want to talk about is that we want to always look for common factors before we do anything else. So always check for GCF and factor that out first. So number 1 says 3x cubed plus 15x squared minus 18x. And notice right off the bat, 3, 15, and 18, they all have a 3 in common, so we're going to factor out the 3. And they also all have an x in common, so our GCF is 3x. So factor out a 3x, and then write out what we're left with. And again, remember, factoring out the GCF is the same thing as dividing out. So 3x cubed divided by 3x leaves me with just an x squared because I subtract my exponents. 15x squared divided by 3x leaves me with plus 5x. And negative 18x divided by 3x leaves me with minus 6. So now I have a trinomial that has a leading coefficient of 1, and this is how we factored on last Thursday. So again, I know 2 sets of parentheses. I'm looking for what can I multiply together to get negative 6, but add to get a positive 5. So I know that 6 and negative 1 will multiply together to get me negative 6, but they will add together to get me a positive 5. So this is going to be 3x, x plus 6, and x minus 1. This entire thing is the answer that has been factored. Okay, so my factors are 3x, x plus 6, and x minus 1. Right, so number 2, 5x squared minus 35x plus 50. Again, check for a GCF. They all have a 5 in common this time. So if I factor out a 5, then I'm left with x squared minus 7x plus 10. And again, now I have a trinomial that has a 1 as a leading coefficient, so I know that I can easily factor that. I'm looking for what can I multiply together to get 10, add together to get a negative 7. Again, this is a negative and then a positive, so I know that both of my numbers will be negative. So this is going to be x minus 5 and x minus 2. Because negative 5 times negative 2 is positive 10, but negative 5 plus negative 2 is negative 7. So number 3, I have 6x cubed plus 30x squared plus 24x. Again, check for GCF. So I notice that everything has a 6 in common. As well as an x. So factor out a 6x, and then I'm left with x squared plus 5x plus 4. Again, now I see that I can factor that easily. So the 6x, 2 sets of parentheses. What can I multiply together to get a positive 4? But add together to get a positive 5. That's going to be x plus 4 and x plus 1. All right, so now we're going to understand factor by grouping. So if ax squared plus bx plus c is a product of binomials, how are the values of a, b, and c related? So let's go back to multiplying 2 binomials together. So the FOIL method. So I would get 3x times 2x plus 3x times 1 plus 4 times 2x plus 4 times 1. So 3x times 2x gets me 6x squared plus 3x plus 8x plus 4. And then our last thing that we did was combine like terms. So I have 6x squared plus 11x plus 4. In the middle step, the coefficients of the x terms 3x and 8x add to form 11x. They're composed of pairs of the coefficients and constants from the original product. If ax squared plus bx plus c is the product of binomials, there is a pair of factors of ac that have a sum of b. So now we're going to look at factoring ax squared plus bx plus c by grouping. So consider 6x squared plus 11x plus 4, where a is equal to 6, b is equal to 11, and c is equal to 4. So now we're going to multiply AC. So 6 times 4 gets me 24. We want to find the factor pair of 24 with a sum of 11. So now, if we have a leading coefficient bigger than 1, we multiply that by our constant. And that's what we're looking for the factors of, that will still have a sum of our middle number. So here I'm looking for the factors of 24 So let's see, I know that 2 and 12 will add together to give me, will multiply together to give me 24, but when I add 2 and 12, I get 14. So that's not what I'm looking for. I know that 6 times 4 gets me 24. When I add them together, I get 10. 8 times 3 gets me 24. When I add them together, I get 11. So this is what I'm looking for, my 8 and 3. So step number 1 will be to rewrite the bx term as the sum of the two factors. So I'm going to write 6x squared plus, instead of 11x, I'm going to use 8x and 3x. So plus 8x plus 3x plus 4. Sorry, I need to change the way that I wrote that. I'm going to write 6x squared plus 3x plus 8x plus 4. Right here, okay, you will usually put the smaller number first. You want to look to see what numbers are going to have a GCF when you combine them together. So then our second step, we're going to group as two binomials. So really I'm looking at 6x squared plus 3x plus 8x plus 4. So that's really what I'm looking at. Step number 3, we want to factor out the GCF of each binomial. At this step, you should have the exact same thing in both sets of parentheses, what was left after pulling out the GCF. So if I only look at the first set, 6x squared plus 3x, and I'm looking for their GCF, the greatest common factor, I see they both have a 3x in common. So then what's left? So if I pull out a 3x, I'm left with 2x plus, if I pull out a 3x from 3x, so we talked about this a little last week. Remember that this is dividing. 3x divided by 3x, anything divided by itself is a 1, so I have 1 left. Plus, now 8x plus 4. What can I pull out of 8x and 4? They both have a 4 in common. So when I factor out a 4, 8x divided by 4 leaves me with 2x. 4 divided by 4 leaves me with plus 1. And so again, here, notice I have the exact same thing in both sets of parentheses. If that does not happen, then you either grouped them incorrectly or this will not factor by grouping. Step number 4, combine the GCF from each group to form a factor. So what you pulled out of each, that becomes one set, 3x plus 4. And then 2x plus 1 is my other one. So the 2x plus 1, I only write it down one time. The 3x plus 4, the GCF from both of them, that becomes my other set of parentheses. Step number 5, remember we can always check our answers, so FOIL. So I get 6x squared plus 3x plus 8x plus 4. When I combine like terms, 3x plus 8x gives me 11x. I have 6x squared plus 11x plus 4, and we go back. That's exactly what we started out with to factor. So we know that we have factored that correctly. Okay, so let's practice a bunch of these. So number 1, 10x squared plus 17x plus 3. So first identify A is 10, B is 17, and C is 3. So now we're looking at AC. AC is 10 times 3, which is 30. We want our factors of 30, and we want the sum of them. I know 6 times 5 gets me 30. If I add 6 plus 5, I get 11. I'm looking to get 17. 10 times 3 gets me 30. When I add them, I get 13. 15 times 2 gets me 30. When I add them, I get 17. So those are the numbers I'm using. I'm going to put my smaller number first. So out of 15 and 2, 2 is smaller. So I'm going to rewrite this 10x squared plus 2x plus 15x plus 3. So I rewrote that 17x there as 2x plus 15x. Now I'm going to group them. The first set, 10x squared plus 2x, I can take a 2x out of both of them. When I divided 2x out, I get 5x plus 1. Now 15x plus 3, I can pull a 3 out of both of them. 15x divided by 3 leaves me with 5x. 3 divided by 3 leaves me with plus 1. Again, I know that I've done this correctly because I have the exact same thing in both sets of parentheses. I combine my GCFs. That's one set of parentheses. So 2x plus 3 and 5x plus 1. That is my answer. Those are both the factors of 10x squared plus 17x plus 3. Okay, let's look at number 2. 2x squared plus x minus 21. A is equal to 2. B is equal to 1. C is equal to negative 21. AC is 2 times negative 21, so I get negative 42. I'm looking for the factors of negative 42. I know that I can multiply 6 and 7 together to get 42. I'm trying to add them to get a positive 1. So if I have a negative 6 and a positive 7, I get a negative 42, and add them to get a 1. So I'm going to rewrite this, and out of those, my negative 6 is smaller. So I'm going to write 2x squared minus 6x plus 7x minus 21. So negative 6x plus 7x is the same thing as saying plus 1x. Group them. 2x squared minus 6x, I can pull out a 2x, and I'm left with x minus 3. 7x minus 21, I can pull out a 3, and I'm left with I can pull out a 7, and I'm left with x minus 3. Group my GCFs, so 2x plus 7 is the first factor. The second factor is x minus 3. So next set, number 3, 3x squared minus 2x minus 8. Again, identify A as 3, B is negative 2, C is negative 8. AC is 3 times negative 8, which is negative 24. What can I multiply together to get negative 4? I know negative 8 and positive 3, that's what I just did. That gives me a negative 5. That's not what I'm looking for. I know 6 times 4 gets me 24, so negative 6 and a positive 4 gets me a negative 2, which is exactly what I'm looking for. So I'm going to rewrite this. The negative 6 is smaller, so 3x squared minus 6x plus 4x minus 8. Group them. Pull out greatest common factors. So out of the first set, 3x, and then I'm left with an x minus 2. 4x minus 8, I could pull out a 4, and I'm left with x minus 2. Combine my GCF, so 3x plus 4, and then what was left behind, x minus 2. That is my answer. Right, so number 4, 10x squared plus 3x minus 1. A is 10, B is 3, C is negative 1. So AC, I get negative 10, and then I'm looking for the sum. I know that I can multiply 5 times negative 2 to get negative 10 and add together to get a 3, which is what I'm looking for. Negative 2 is smaller, so I'm going to write this as 10x squared minus 2x plus 5x minus 1. Group them together. 10x squared minus 2x, I can pull a 2x out, and I'm left with 5x minus 1. 5x minus 1. The only thing that they have in common is a 1. You can go ahead and pull out a 1 when you're factoring by grouping. So I'm going to pull out that 1, and I'm still left with 5x minus 1, which is exactly what I need, because it's exactly what was in this first set of parentheses. Combine my GCFs, what I took out, 2x plus 1, and 5x minus 1. That is my answer. Number 5, 3x squared minus 20x minus 7. So I'm multiplying my A and my C. So I'm looking for what can I multiply together to get negative 21. But when I add them, I want a sum of negative 20. Well, I know the only way that I'm going to do that is from negative 21 and a 1, and that's going to get me a negative 20. So I'm going to rewrite this. 3x squared minus 21x plus 1x minus 7. Again, group. I can pull out a 3x from the first ones, and I'm left with x minus 7. And notice I already have an x minus 7 over here, which is telling me I'm only going to be pulling out a 1 as my GCF. So when I combine my GCFs, I have 3x plus 1 and x minus 7. That is my answer. Number 6, 2x squared plus 7x plus 5. Again, multiply A and C. 2 times 5 gets me 10. I'm looking to get a sum of 7. I know that 5 times 2 gives me 10 and adds together to get me 7. So I'm going to rewrite this as 2x squared plus 2x plus 5x plus 5. Group them together. I can pull a 2x out of the first one, and I'm left with x plus 1. I can pull a 5 out of the second one, and I'm left with x plus 1. Combine my GCFs, 2x plus 5, and then what I was left behind with everything, x plus 1. So my answer, 2x plus 5 times x plus 1. Number 7, 12x squared minus 5x minus 2. Again, multiply a and c, and I get negative 24. I'm looking to get a negative 5 as my sum. I know that negative 8 and positive 3 give me a negative 24 when I multiply and give me a negative 5 when I add. So 12x squared minus 8x plus 3x minus 2. Group them together. The first set, I can pull out a 4x, and I'm left with 3x minus 2. 3x minus 2 is what I'm left with over here. The greatest common factor between them is 1. And again, I already noticed that's the exact same thing that I just ended up with here, so I know I'm just pulling out that 1. And I'm still left with 3x minus 2. When I combine my GCFs, I get 4x plus 1 and 3x minus 2. That is my answer after I have factored. We're going to do a lot more examples. So on the back, number 8, 15x squared minus 10x minus 5. Right off the bat, I notice I have a 15, I have a 10, and a 5. And remember at the very beginning, I told you always check for a GCF before you do anything else. So at the very beginning, we're going to make our life easy here and go ahead and pull out a 5. And then I'm left with 3x squared minus 2x minus 1. So now this is, I want to take A as 3, B negative 2, and C negative 1. So AC is negative 3, and I'm trying to get a sum of negative 2. So I know that that's going to be a negative 3 and a positive 1. I still have this 5 out here. I can't forget about him. So then I'm going to rewrite this as 3x squared minus 3x plus x minus 1. I'm going to group these two together. I'm going to pull out a 3x here, and I get x minus 1. Over here, all I can pull out is a 1. And I'm just left with x minus 1. So when I factor it, I cannot forget about the 5 that I pulled out at the very, very beginning. So I have a 5, and then combine the GCFs of the two groups, 3x plus 1, and then x minus 1. So this whole thing is my answer factor, 5 times 3x plus 1 times x minus 1. Number 9, 3x squared minus 2x minus 1. I'm looking to multiply together, get a negative 3, but add to get a negative 2. I know, again, that's a negative 3 and a positive 1. So I'm going to rewrite this as 3x squared minus 3x plus x minus 1, which is the exact same thing that we just had above. So I know I'm taking out a 3x, and I get x minus 1. I know here I'm taking out a 1, and I get x minus 1. So that factors to 3x plus 1 and x minus 1. So number 9 was really what I ended up with after I pulled out the GCF of a 5 from number 8. Number 10, 35x squared plus 17x plus 2. Multiply 35 and 2 together. So I'm looking for what factors give me 70. I know 10 and 7 give me 70. When I add them, I get 17, which is exactly what I'm looking for. So I'm going to rewrite this as 35x squared plus 7x plus 10x plus 2. Group them. 35x squared and 7x, I can pull a 7x out, and I'm left with 5x plus 1. 10x plus 2, I can pull a 2 out, and I'm left with 5x plus 1. Combine my GCFs, 7x plus 2, and my 5x plus 1. And that is my answer. Number 11, 12x squared plus 20x plus 3. I don't have anything in common I can pull out at the very beginning, so I go straight to multiply a times c. So 12 times 3 gets me 36. I know I can multiply 12 and 3 together, but when I add them, I get 15. 6 and 6 gets me 36, but when I add them, I get 12, and I'm trying to get a 20. 2 and 18 get me 36, and when I add them, I get a 20. So I'm going to rewrite this: 12x squared plus 2x plus 18x plus 3. Group them, pull out their GCFs. So here I can pull out a 2x, and I'm left with 6x plus 1. 18x plus 3, I can pull out a 3, and I'm left with 6x plus 1. So when I combine, I get 2x plus 3 and 6x plus 1. That's my answer factored. Number 12, 5x squared plus 17x plus 6. They don't have anything in common. Multiply a and c, 5 times 6, and I get 30. I know 5 times 6 gets me 30, but when I add them, I get 11. I'm trying to get a 17. 15 times 2 gets me 30. When I add that, I get a 17. So I'm going to rewrite this as 5x squared plus 2x plus 15x plus 6. I'm going to group them. 5x squared plus 2x, the only thing they have in common is an x. So then I'm left with 5x plus 2. 15x plus 6, the greatest thing they have in common is a 3. 15x divided by 3 is 5x. 6 divided by 3 is plus 2. My GCFs, x plus 3, and then what I ended up with in parentheses, 5x plus 2. There's my answer. Our last one that we're going to do, 6x squared plus 7x minus 5. Again, multiply a and c together. 6 times negative 5 gets me a negative 30. I'm trying to get a positive 7. Negative 6 and a positive 5 get me a negative 30, but add to get me a negative 1. 10 and negative 3 give me a negative 30, and add to give me a positive 7, which is what I'm looking for. So I'm going to rewrite this as 6x squared minus 3x plus 10x minus 5. Group them together. The first set I can pull a 3x out, and I'm left with 2x minus 1. The next set I can pull a 5 out, and I'm left with 2x minus 1. So when I combine, I have 3x plus 5 and 2x minus 1, and that is my answer. All right, so we just did a lot of examples of factoring trinomials when our leading coefficient is greater than 1. So remember, always check for a GCF before you start. Then multiply your A and your C together, and you're looking for what can I multiply together to get that number, but add together to get my B term. Put your smallest term first, so rewrite that using those two numbers, putting the smallest one first, and group them together, taking the GCF out of both of them. Combine the GCF as one factor, and then you should have had the exact same thing in parentheses after you factored out your GCF, and that becomes your other factor. So that is our lesson on factoring trinomials when your leading coefficient is greater than 1.